right? I think you'll remember this storyline, right? Where one of the ghosts, she passed away on the island. Here's what I need for everyone to do. You don't need graph paper, but you can take your pencils and your rulers and quickly draw what's on the screen here, right? Let me get the points. This here, I'll just call this point A, and here will be what? I think over here is minus 7, 1. I will call here point B, which is minus 9, 7. And over here, C, minus 5, 7. Let me know when you are, right? So this question is a little bit different from the other questions we did last week. In this question, they gave us a center of enlargement. The center of enlargement was 3 minus 1. Now I already put in what? The 3 and the minus 1. This over here is the center of enlargement. So apparently there was a triangle here, a smaller triangle, and apparently when they enlarged that triangle, you got the larger triangle, which is on the screen at the moment. So we are trying to find back the original triangle. The scale factor is what? 2. So here's what you're going to have to do. You're going to take 1 point at a time. Let's just start with point A. You are going to connect point A to the center of enlargement. So take your ruler and connect A to the center of enlargement. And I want you to measure the length of that line with your rulers. Now, everybody's going to get a slightly different answer for the length because we're not using actual graph paper, and everybody's going to draw the graph slightly bigger or smaller. But anyway, draw the line to the best of your ability, measure the length, and send the length to me of the entire line. All right, so let's see how this is looking, right, so far. Right, you're connecting all the points to the center of enlargement. For the red line, you're measuring it and you're dividing the length by 2. For the blue line, you're measuring it and dividing it by 2, and similarly for the green line. Up to yours. Did it look something like that? Look at it. And I could prove to you, right, that this triangle is half the size of the larger one, right? I can take a sample side, from B to C was 1, 2, 3, 4 blocks. Now look at it over here, the red triangle. The corresponding side is only 1, 2. 2 is half of 4. All right. So at the end of the day, right, if the scale factor was 2 and you're trying to get back the original triangle, you're measuring the length and dividing by 2. It's kind of a common sense. It's not like it's It's something that a normal person might have thought about anyway without my assistance, right? So take a few seconds, finish it off, and don't worry, you have a next exam. So the next question. All right. Oh, okay. The next one was Jenny. So apparently when Jenny was alive, her most precious item was a set of bow and arrows. So remember, we finally find it for her. When we touch it, it's going to give us a vision. Right? So in the next slide, we will find out why it was precious to her. I want everyone to draw this diagram as well. All right, let me put in the coordinates so you can see it. This coordinate here, A, it looks like what? A looks like 3, 5. I'll call this one B here. 9, 5. And C looks like what? 6 minus 4. Draw that and have it ready when you're finished. For those of you all who want to take a shot at the question is in blue. Feel free to try it. So your working should look something like this. You're going to connect a line from A to the center of enlargement. You will measure the length of that line. Now, I just say if the length of this line was 9 centimeters, you find 1/3 of that. So it will be 3 centimeters because 1/3 of 9 is 3. And you do the same thing for point B, that's the blue line, and then for point C, which is the red line. Did it look something like that? If you look at it, from here to here is 1/3 of the line. The remaining portion would be 2/3, obviously, because 2/3 plus 1/3, well, is 1. Look at my working and see if you ended up with something like what I had here. This point would have been, I'll call it A prime, would have been -3, roughly -3, 3. This point here, B prime, would be how much? -1, 3. And this one here is pretty easy. He is -2, 0, roughly, right? So let's see what's going on with this bow and arrow and why it was so important to Jenny. Right, so apparently it's Romania, 1477, medieval times. That's Jenny there. So that's a little, we'll see how this leads up to the bow and arrow in a little while. All right, so we reached something a little bit different now. We just finished enlargement. Now we are going to do rotations. Now, whenever we're doing a rotation, like when you're rotating something, think about it, like the hands of a clock. It can either rotate clockwise or the opposite is what? Anti-clockwise. A couple weeks ago, you all would have seen this formula somewhere at the beginning of when we started transformations. And there were 2 formulas, one for anti-clockwise and one for clockwise. Now the 2 formulas look almost the same. It's just that the minus sign here is this B down here for the clockwise one, right? So according to this question, right, we want to rotate this triangle by 90 degrees anti-clockwise. That means we're spinning it this way. This formula only works if the center of rotation is the origin. Now, for all practical purposes, I'm going to assume that this question, the center of rotation is the origin. To do this question, don't let the cosine, sine, and cosine, how you say, scare you. If the examiner were to tell you 90 degrees, all you have to do is go and replace everything in red with 90 degrees. If he told you to rotate it by 270 degrees, you would go and replace everything in red with 270. Do me a favor. So in other words, this is what you're seeing. Cosine 90 minus sine 90, sine 90, and cosine 90. All you have to do is go on your calculator, type in cosine 90, you will get a number. Type in minus sine 90, you will get a number. In other words, when you are finished, you will have 4 figures. Get those 4 figures for me, and I have my calculator here for those who are a little confused, right? If you wanted to find cosine 90, you just press cosine 90 and press equal. You're supposed to get 0 on your calculator. Confirm that when you press cosine 90, you get 0. Make sure your calculator is on degrees mode. Make sure the top of your calculator is in degrees mode. Make sure you're seeing a DEG or the letter D and not, but by now everyone in form 4, form 5, so you should be able to, by now, to set your calculator to degrees mode, right? Okay, how about minus sine 90? Now, when you're typing in minus sine 90, you're using this minus button here, not the regular one, this one here. Minus sine, press 90, and you're supposed to get minus 1. So make sure you're seeing a minus 1 here. Then type in sine 90. So sine 90, and I get positive 1. And the last one, well, we did this one already. Cos 90 is 0. So in other words, this matrix in front of you, if you apply it to all the points on the triangle, it will look like the new triangle got rotated by 90 degrees in an anti-clockwise direction. Now, I'm not going to review how to multiply matrices. We had 2 weeks of it, plus you had homework on it. So here's what I need for you all to do. I will call this point A, I will call this point B, and I will call this point C. I want everyone to take this matrix and multiply it by point A. Point A is 4, 1. And tell me what you get for the new point A, A prime. The first one. When we multiply this matrix by 4, 1, I am getting minus 1, positive 4. And I think that was the most popular answer on the chat, right? Minus 1, and we go up to 4. That should be somewhere around here. So I'll put in the points for the examiner, minus 1 and 4. Have a little comma there. No, it's hard to see. So it's just a repetitive process, right? All we have to do now is take this same matrix and multiply by which point now? Point B, which is 7, 1. And when we multiply by 7, 1, you'll get two more values here. You plot it, and you do the same thing for point C. Right, so take a 30 seconds again, and then I will jump in. All right, so let's see what we got for point B. When I multiplied by point B, I got minus 1, 7. That's for B prime. Let's see how that looks here. -1, and we go up to 7. So this is B prime. I should have put a little prime here for E. So B prime is how much? -1, 7. And for C prime, right, I have a good feeling I'm going to get -6 all the way up to 4. But confirm it on your end, right? Because sometimes I do make mistakes. And when you connect it, your triangle will look like that. Right? Confirm it on your end. If you choose to draw this one, feel free, but it's not necessary to draw it. But if you just want to follow along for this one, right? Because I didn't give specific instructions to draw it. I should have clarified that at the beginning. All right, so we just took this triangle and using the rotation formula, we claimed to have rotated it by 90 degrees in an anti-clockwise direction. Rotating something, it takes a little bit more imagination than doing what? Reflections or even doing enlargements. How can we test to see if we actually rotated it by 90 degrees? Like, there's a small test you can actually do in the exam. So when you leave the exam, you can be confident in your answer. If the center of rotation is, in fact, the origin, here's a small little test. Take any point on the original triangle. For those who already drew the diagram, take a ruler, connect point A to the center of rotation, which just happens to be what? The origin. So for those of y'all who did it, who drew the diagram, connect A to the origin. For those who didn't, you just follow along. When you connect A to the origin, connect it to its rotated counterpart. So you go from A to the origin and then move it to A prime. You see this angle here? Does it look like 90 degrees? What do you all think? From just looking at it, does it resemble 90 degrees? Is that a right angle? It's looking like a right angle, right? So most likely you're on the right track. And if you draw the arrow like this, you'll see that this line got rotated by 90 degrees. Now, don't do the test for 1 point, at least do it for 2 points so you can feel a little secure. You see this green line in the exam? What I would have normally done, I would have drawn that very, very light. So only you could really what? See it. This is just for peace of mind. Let's take another sample point. Let's take point C. Take point C and connect it to the origin. And when it hit the origin, let it bounce to its brother point, its counterpart. It's easy when you use different colors, right? You will notice that the blue lines also look like they are 90 degrees apart. And believe me, if you do the same thing for point B, it will also look like 90 degrees. So if this were an exam, I know I could leave the exam stress-free. Like, at least I did a check to see if my answer was correct. All right, so take a 30 seconds, take down what you need to take down, and we will be moving on. Let's see what happens to Jenny. Right, so she was dragged outside and she was hanged. But what does the bow and arrow have to do with this? Up to now, we haven't seen the significance of the bow and arrow. Someone said Robin Hood. All right, so apparently when she was hanged, she wasn't hanged proper. Hang or hung, I not good at English. Right, so she wasn't hanged properly, so she was still barely alive. So we'll see what happens in a little while. So the next, well, this one here is something we just discussed. You don't have to draw this. Let's say, remember we just did this question, right? Where we were asked to rotate this triangle by 90 degrees, and this was the answer we got over here. So what I'm putting forward to you is, could this question have been done without matrices? And the answer is yes, you know. If you wanted to rotate this by 90 degrees in an anti-clockwise direction without using matrices, all you would have to do is take one point connected to the origin, measure the length of this line. Let's just say for simplicity's sake, the length of this line was 5 centimeters. You would then have to use your protractor, measure 90 degrees, and then when you measure the 90 degrees, how long do you think this line will have to be? If the original line was 5 centimeters and you measure 90 degrees in an anti-clockwise direction, what would be the length of this line? It will also be what, 5 centimeters. And if you did that procedure, you would get the same answer as if we did it with matrices. So for this point, all we would have to do is take our ruler, connect it to the origin, because that's the center of rotation. If the length of this blue line was 7 centimeters, if we measure 90 degrees using our protractor, and we draw this other dashed line, 7 centimeters in that same direction, right? So I guess for rotation questions, there are two ways you can do it. You could use the matrices, or you could use the drawing method. Before you ask the question, the examiner most of the times will specify which method he or she wants, whether it's calculations, that is matrices, or using a drawing method. If the examiner does not state which method to use, obviously it's open to you. You can use any method. But just asking, which one would you prefer? And people are going to be divided on this. Which one is more convenient for you? Drawing or the calculation? Which one would be easier? A lot of people are saying the matrices method. Poor Jenny is just hanging from a noose there. Oh, this was the drawing here to show you how to do it. You notice I'm taking each line and drawing it 90 degrees apart. Right? So here we have, oh, the sun has begun to go down, so it's late in the evening. Right, so someone in the forest shot an arrow, freed her, right? Right, so she tried to find the person, but apparently all she found was a bow and arrow used. So I guess she never figured out who saved her, right? So she kept it as a souvenir. All right, so that's Jenny's story. Let's see what's going on with this question. Here you all have a question to try on your own. I want you to draw this one out for me completely, and I want you to do the calculations. I will call this one point A, this one point B, and this one point C. This time, well, we're going to assume that the center of rotation is the center, the origin again. And this time it's 180 degrees, not 90 degrees. And I want you to use calculations. Get started. Let's just make sure we have all the values correct. Cosine 180. If I type that in, cosine 180, I am getting minus 1 over here. I think I'm getting minus sine 180. I'm thinking that I'm going to get 0. Sine 180 is another 0. And cosine 180 is minus 1. How much of y'all could agree with those 4 values? And all we have to do now is just take this matrix minus 1, right? Minus 1, 0, 0, minus 1. And we just have to take this matrix and multiply by each point individually. So just as a little starters, we're just going to take point A and put minus 8 and 4. Now, my advice is that you take your time and multiply it out. I know some of you may see a pattern, like when you take this matrix and multiply it by these points, you may see a pattern repeating itself. My advice is do not use the pattern, rely on doing the full calculations, because I know the examiner, for one, is going to give you marks for all the calculations. All right? And sometimes patterns could be misleading. You may think you saw a pattern when it's really not a pattern, and then you end up getting the entire question wrong. This one, sorry, I got distracted. For the first one, I am getting positive 8 and minus 4. Make sure the signs are correct. This is A prime. 8, let me see if I can draw that in on my diagram here. 8, and we're going down to minus 4. This is A prime here, right? Ooh, I should have write that a little bit better. We got a different color here. A prime. 8, kind of hard to see, but 8 minus 4. Right? And what you're going to do, the same thing for all the points, right? Replace here with B, calculate. Replace here with C, calculate. Give you a few seconds. So just for recording purposes, everything in pink here is the answer. But do you all think we can do a check? Remember, when we were doing a rotation of 90 degrees previously about the origin, there was a way to check. We would, we would connect similar points via the origin and ensure that the angle was 90 degrees. Today, we can do the same thing. We just have to make sure the angle is how much? 180. And in case you all cannot remember, don't remember, a straight line is how much degrees? 180. So let's see if we have this. Let's do one test point. Let's take C, since the C's are so close. If I take C and connect it to the origin, and then from the origin go to C prime, you all notice something? I get a perfect straight line. And not only a perfect straight line, the lines on either side are the same length. Look at this green line here. Just by even looking at it, you can see that this length and this length is the same. And together, they form a perfectly straight line, which is 180 degrees. Do that for any of the points. Take B, connect it to the origin, and then from the origin, go to B prime. You'll get a perfectly straight line. And once again, straight lines are 180 degrees in total. For those who did the drawing, just connect a couple of them just to confirm it, just so it sticks in your memory. Connect the C's and then connect the B's. And see for yourself, it's a straight line. Remember. Let's see. Oh, that's not. Oh, that's one by mistake. All right, so apparently, well, this is the object that's, let's see the name of the, Mary's most precious item is a strange looking relic that you find outside the house, apparently in the shrubs. Anybody wants to take a guess of why this relic is so important to Mary? Somebody has a good theory that she was the queen of Egypt. Someone said someone gave it to her. All right. So we're going to see in a little while why this relic was so important to her. Right. So let's see what this question is about. Read this question. Don't start to draw it as yet. Just read it. Do you all think that we can do this by calculations? What do you all think from just looking at the question? Or someone had a good, someone says a family heirloom. I would say the answer to that question is no, because look at it. Please note the center of rotation is no longer the origin. It's the 0.14. And I'll notice that I draw it in for you. I actually put the center of rotation there, which means, right, we could only use a drawing method. Everyone draw this as neatly as possible and wait on me. You'll need to do this together with me. When you are finished with your very, very neat drawing, let me know. Notice in the question, they said to rotate it by 270 degrees clockwise. Now, in case you can't remember, clockwise is this direction. Let's assume that we are standing at point X. So I have a little cross here. Now, as you all remember, each part of the cross is 90 degrees. I think you all could see that. Let's say we start at X and we turn 90 degrees clockwise. So we rotate in clockwise. So that is 90 degrees. We reach here. We continue turning 90 degrees. When we reach here, we continue turning 90 degrees. How much degrees? And so let's say we ended up at this point here, and I'll call this point P. How much degrees did we turn clockwise in total? What's the total clockwise rotation for my made-up question? I would, right, and everyone is saying the correct thing. It's 270 degrees. 90 plus 90 plus another 90 is 270 degrees. Now, at the end of the day, when it comes to rotation, nobody actually really cares how much degrees you rotate. What is actually more important is where you start and where you finish. So let's say someone closed their eyes, right? So you started at X and they closed their eyes, and a few minutes later, they open their eyes. All they will see is that you ended up at point P. Now, you took the long way around it. Isn't there a shorter way to reach from X to P? You don't have to go all the way around. Couldn't you just simply go this way? Right. So if we chose 90 degrees anti-clockwise, we would have still ended up at P. In other words, this is what I'm trying to say. Rotating 270 degrees clockwise is the same exact thing in maths as going 90 degrees anti-clockwise. Because at the end of the day, we end up in the same exact position. So instead of, whenever we're rotating, whenever we're using our rulers and protractors, which angle do you think is going to be easier to measure? 270 or 90 on a protractor? Which one is obviously going to be easier to remember? I mean, not remember, to do. 90 degrees. So we're going to use 90 degrees. Look how easy this question is going to be, right? Using a ruler, remember here is the center of rotation. Let me see what I have planned out here. I want you to take your ruler and connect point B to over here, to the center of rotation. And of course, I want you to measure the length of that line. Everybody's going to get something slightly different because not everybody is using craft paper. Connect B to the center of rotation. Then, whatever you get for the length of this line, move it downwards. You know why we move it downwards? Isn't this angle over here 90 degrees? And look at it. This is 90 degrees anti-clockwise, which is the same thing like as 270 degrees clockwise. So by moving it 90 degrees anti-clockwise, I'm doing the exact instructions the examiner is asking me to do. And I want you all to do the same thing for the next point now. This one is kind of hard to see, right? It's overlapping the other line. Take point A, connect it to the center of rotation, measure the length of that line. It should be easy to approximate how much is 90 degrees on a graph paper and move it the same length downwards. So we did it for B, now we're doing it for point A. And of course, we have to do the same thing for point C. Connect C, that's the green line, to the center of rotation. Now we have to make a 90 degrees, right? And that's our 90 degrees here. And both green lines are the same exact length. I have a good feeling when we join that up. Look at it. That's our final answer, right? Here would be B prime, A prime, and C prime. Please confirm with me when you get something resembling what I have on the screen. Wow. So here we have a spooky looking cabin in the middle of, I guess, somewhere in Colorado or something. Oh, it's 1709 in Canada. All right. How much of you all find this is out of place, that Mary should be, she's well dressed and she's in the middle of the woods? Any theories here of what's going on? Why is she walking in the middle of the woods, in the middle of nowhere? Kenya, I like your assumption. All right. Plenty. Nobody has any when I say the word good, you all always assume the worst. All right, we'll see what happens in a little while. And the year was 1709. All right. So how much of you all have done this topic in school already? How to bisect a line, like cut a line in two using a compass. In case you don't know what a compass is, it's that thing with one pointy edge here and there's a kind of a pencil on the other side here. Right? Now, I'm just going to refresh your memory on how to bisect a line using a compass, right? And I'm going to show you this two ways, okay? If there's a line on the screen, right? I'll draw it, I'll draw it a little too large. Let's say that the examiner gives you a line, and the line starts at A and it ends at what? B. To cut this line in half without measuring it and what? Using a ruler, all you have to do is take your compass, put it at one end, and open it to a little more than half the line. It has to be more than half the line. It could be 3/4 of the line. Just make sure it's more than half. So you open it and you scribe an arc. Now, move to the other end of the line now, point side B. And from B, using the same distance between the point and the pencil, from point B, scribe another arc. The two arcs will meet on top and underneath. All you have to do is connect those 2 points. And you see this dashed line, it will cut the original line in half, exactly in half. Now, this is a Form 2 topic, but it might be a little rusty in your head. All right? So I'm going to show you, I'm going to see if I can get a video on this. I think I had embedded a video on how to bisect a line. Okay? So if you didn't catch it there, don't worry. Let's see if it's on the next slide. So here's a little video on how to bisect a line. So watch the video. This is one of my videos, by the way. So what you're going to do, you're going to draw a line. And we're going to try to bisect this particular line. So the original line is AB. You open your compass to a little more than half, you scribe an arc. That's where the two arcs meet. Right? And you see this black line, it will cut the red line in exactly 2 exact pieces. All right. Now, if you're still a little bit lost, right? After class, I can recommend a whole video that shows you everything to do with the compass on the CXC syllabus. All right, so let's move ahead and let's see what's next on the list. Oh, we gotta get back to Mary here. That's the relic there. So for whoever guessed that she was a werewolf, you all were correct, and she was on the hunt. All right. All right, so I need for everyone to draw this diagram for me. This graph here for me. All right, let me label it A, B, and C. All right, for homework, all you need to do is go to the maths classroom. Right, so when you go into the maths classroom, you're going to scroll down to lesson 23. Make a note, that's construction of angles. The construction of angles is a standard topic that will come in your CXC exams. Now, it includes creating angles using a compass, but it also shows you over and over how to bisect a line or to cut a line in half, which you will need for next week, plus a compass. All right, for those who are doing technical drawing TD, you are exempted from the homework because most likely you have that theory inside out. Okay, guys, so once you understand what the homework is, you are free to leave, right?